Good morning, children. It's Sanjeev Pal from Srimati LPSAVANI VIDHYABHAVAN, your statistic educator, welcoming you all to the class of statistics. Here, children, we shall see to the first example. See example number 1. What has been given? That in a television manufacturing company, 500 television sets are produced during a week. A sample of 50 television sets is drawn and each television set is examined. The number of defects per set is given below. Prepare an appropriate frequency distribution. Now see, children, what they given over here? There is a sum where you would find what they given, that a television manufacturing company is there. In a week they are manufacturing 500 television sets and they are just taking 50 samples out of them just to know how many defects are there into those 50 television sets. So you would find the numbers that has been given to us, that is 0, 2, 2, 0, 3, 3, 4, 1. All these numbers that you find on the screen are what are the defects into those 50 television sets which are for samples. So now what we need to do over here is that, first of all, because the numbers have been given to us, okay, and we need to do the frequency distribution, what we need to do, first of all, try to find out what is the highest number and try to find out the lowest number. By this, what you are finding the range. So over here we need to find out the range, that is, you would say highest observation minus the lowest observation. I repeat, highest observation minus lowest observation. If you will see this minutely, all these numbers, if you will see that, you will find that in this the highest number is 5. Can you see? If you observe, okay, minutely all the numbers, you would find that the highest number is 5 and the lowest number that you will find is 0. So that's why your range becomes what? Your highest observation minus the lowest observation, that is 5 minus 0, that is 5. Here the range is what? The range is 5. Continuing with the same sum, you would find, see the number of defects per television sets. We had seen the lowest number was 0 and the highest number was 5. So we wrote them vertically. Number of defects per television set, that is given as x variable, that is our first column. Into this first column we just wrote all the defects found into those 50 television sets. There were defects from 0 to 5, so we wrote the numbers 0, 1, 2, 3, 4 and 5. Then you would find we have put up the tally marks seeing to the number of the defects given into the sum, right? After putting the tally marks, children, tally marks you have very nicely done in your standard 10. Seeing to all those numbers from the sum, what you are going to do, you are going to put marks, okay, in front of those defective numbers, that is 0 to 5. You are going to make the group of 5, right, and till you just complete those 50 defects. So these are the tally marks how that has been put, okay, with the group of 5, right? Then you will count them and that will give you the frequency, that is the number of television sets. The first one you would find is actually 18, that is 3 groups of 5 each plus 3, that is 18, then 2 groups of 5 each and 2, that's giving you 12, then 5 plus 4 giving you 9, 5 plus 1 giving you 6, 3, then 2, the total should come up to 5050. Children, make note over here that it is really compulsory that you give a heading, an appropriate heading to this given table that you have drawn or mentioned. See the heading, a discrete frequency distribution of the number of defects per television set in a sample of 50 units. Over here 50 units are there, right? And you have found out what? You just found out a discrete frequency distribution. That is how you should be doing this sum, right? So this is our first example. Dear children, Now we shall discuss our example number 2. What they given over here in example number 2? Figures regarding the sales in 1000 rupees of different items in a super mall during 4 weeks are as follows. Over here the figures are of the sales in 1000 rupees, right? They have told us to prepare the appropriate frequency distribution, right? Over here, children, you would find that while we talk about say the highest number you would find is 265. If you see every range of the numbers, okay, you would find the highest number has come up to 265. And what is the lowest number? The lowest number is 80. The highest number is 265 and the lowest number you would find is 8080. Now see the line, the question what we were talking about. Construct a frequency distribution by classifying this data into 8 classes. Children, over here they have told us that we need to prepare frequency distribution with 8 classes. Children, as the classes have been given to you. Now what are the classes? Okay, you would find we had already discussed. Over here if you see to this sum, the range 75 to 100, 100 to 125, 125 to 150, 150 to 175, all these are the classes given. These are called the classes. So over here they have given us the number of classes. The number of classes, okay, that has been given to us is k, that is 8, right? That is the number of classes, and the number of classes is denoted by capital K. The number of classes is denoted by capital K. Excuse me. Now we shall find out what is the range. Range we have seen, we always take the highest observation minus the minimum observation. Range you would find, the formula of range is range of the data. Range is also denoted by capital R, that is maximum value minus minimum value. Range of the data is equal to maximum value minus minimum value. We had seen into the sum that our maximum value was 265. The minimum value we had seen was 80. Now if you deduct 265 minus 80, if you deduct 265 minus 80, you will get 185, right? And that is our range. Now why we have found out the range? We found out the range to determine what could be the class length. We found out the range to determine what could be the class length. Now this is the formula of class length. This is the formula for class length. Class length you would find is always denoted by capital C. Class length is always denoted by capital C. Now what is class length? Under it you would find the first class, that is 75 to 100. Okay, 75 to 100. Okay, 100 minus 75 will give us 25. 100 minus 75 will give us 25, and 25 is called the class length. But over here the class length would be found out with the help of the number of class. They have told us to actually have 8 number of classes. So over here you would find the formula for the class length becomes range upon number of classes. I repeat, range upon number of classes. Now range is denoted by capital R and number of classes is denoted by capital K. So range upon number of classes, range we have found out in range 185, the range is 185, right? So for range we are going to take 185 in the numerator, and number of classes they have given in the sum that you have to take 8. We need to take 8. Okay, so you would find that 185 divided by 8 is giving you 23.125. Over here the class is coming in decimal, that is 23.125. But children, the classes are never in range, so we will take a round figure that the class length we will take it as 25. 23.125 is near to 125. is near to say 25, and that's why you would find that the class length will take is 25. So now we shall prepare our say frequency distribution. Over here you have found out that our highest number is 265 and we have seen our lowest number is 80. So we shall start from 75 and we will take a difference of 25. So that's why you would find, see the classes 75 to 100. So the classes is 75 to 100 is then 100 to 125, 125 to 150, 150 to 175. In every class you would find the differences of 25. Why the differences of 25? Because above we have just taken, because it was 23.125, we have taken the class length as 25, and that's why over here the difference is of 25. Then the next class 175 to 200, 200 to 225, 225 to 250, and 250 to 275. That is the number, all the classes. Now see, over here we have seen the highest number was say 265, and this 265 you would find it will come in between 250 to 275, right? And that is our last class. And as you count the number of classes, you would find you got 8 classes. They have told us to take 8 number of classes. So see, 1, you would find that 1, 2, 3, 4, 5, 6, 7 and 8 classes, right? So that is how you prepare or you take the classes. Now what you would do is that you will put up the tally marks, right, from the sum, and then with the help of the tally marks you are going to put up the frequency, that is the number of days. Over here you would find, if we count the marks, okay, there are 4 marks, so it is 4. Over here the frequency is 4. Similarly, okay, for the next class it is 4. Then the next class you would find it is 5 plus 3, that is 8. Then it is over here 2. Then it is again over here 2. Then over here it is 4, and then say 3, and there is only 1 mark, and that's why over here it is 1. If you will count this frequency, children, you would find you will get 28, and 28 is frequency, and you would find the frequency symbolically it is always denoted by small f. It is always denoted by small f. So over here we found out say frequency distribution. And children, it is again I am telling you, it is necessary that you give an appropriate title to the given table. Now see, what is the title given to us? The title given to us is an exclusive, this is an exclusive continuous frequency distribution. An exclusive continuous frequency distribution of what? Of sales in 1000 rupees during 4 weeks. Now over here children, now why exclusive? Why exclusive continuous frequency distribution? Now you would find the continuous frequency distribution are of exclusive type and inclusive type. Now these are of exclusive type. Now just see, why exclusive type? Over here you would find, see children, first of all, this 75, right? If I take this class 75 to 100 and just 100 to 125, okay, you would find over here that this 75 is called the lower limit, this 100 is called the upper limit, right? This is called the upper limit, okay. And you would find with the help of the lower limit and the upper limit, we can also find out the boundary points. How we will find out the boundary points? In the subsequent sums we will see. Now over here 75 is the lower limit, 100 is your upper limit. Now with the help of this you would find children, with the help of this I would like to explain you what do we mean by exclusive frequency distribution. This is a continuous frequency distribution and this is called exclusive. Why exclusive? Now suppose if I take this class 125 to 175, just observe 125 to 175, just a minute. 125 to 175. Now see children, over here you would find the lower limit of the given class, and the upper limit of the previous class are same. See, that is 125. That is 125, right? And you would also find, say, the upper limit of the given class and the lower limit of the subsequent classes are the same, right? Upper limit of the given class and the lower limit of the subsequent, that is the next class, are the same. When this is the case, okay, these are called the exclusive continuous frequency distribution. These are called exclusive continuous frequency distribution, right? In short, okay, बहुत ही क्लियर भाषा में मैं कहना चाहता हूँ, आप देखोगे over here, see the numbers 125 and 125 over here, right? And you would also find 150 and 150 over here for this given class. When this is the case, this is called your exclusive continuous frequency distribution. I repeat, when for the given class, if the lower limit is same as the upper limit of the previous class, the lower limit is the same as the upper limit of the previous class, and the upper limit of the given class, right, is the same as, say, the lower limit of the next class. Okay, at that time we can say that it is our continuous frequency distribution, but exclusive continuous frequency distribution, right? So that's why the heading is of an exclusive continuous frequency distribution. So this is our second sum, right children? Now children, we shall see over here our third example. See the third example over here, that what they given: during a season of 50 days, the data regarding the numbers of roses grown daily on the different plants in a garden are given below. Prepare a frequency distribution from it having one class as 30 to 39. Children, they have given us one of the classes as 30 to 39, and over here there are different plants in a garden are basically given for 50 days. That in a garden, in 50 days, how many plants are actually growing each day, right? So over here, but one they have given one of the classes, that is 30 to 39. So over here again children, our method will remain the same. Whatever the numbers have been given to us, we shall find out the highest observation and then the lowest observation. If you see to the numbers, okay, minutely, right, if you see to all the numbers minutely, you would find that 99, okay, 99, okay, on your screen you would find is the highest observation. Similarly, as you see to each and every observation, again you would find, if you will introspect this, you would find 70, 1717 is actually your lowest observation. So with the help of those numbers 99 and 17, we shall find out the range first. So over here you would find your range is highest observation minus your lowest observation. The highest observation has come up to 99 and the lowest observation has come up to 17. As you deduct 17 from 99, you will get the range 82. So over here your capital R is 82, that is the range is 82. Fine. So over here the first column would be of number of roses, right? Next column obviously the tally marks, because we need to put up the marks as per the total number of roses into the garden. And obviously the last column would be of frequency, that is number of days. I repeat, the first column would be number of roses, right? The second one will be tally marks, and the next one, as the 50 days have been given to us, that's why the frequency would be, or the column of frequency would reflect number of days. and the total shall reflect 50. As we have discussed, it is needed to give an appropriate title to the table. So over here, children, they had given us an inclusive, this is an inclusive continuous frequency distribution, right? An inclusive continuous frequency distribution of the number of roses of the different rose plants of a garden. Alright, now why it is an inclusive continuous frequency distribution? Children, now if I take the class 40 to 49, if I take the class 40 to 49, okay, you would find, see the upper class, or you can say the class above it, it is 30 to 39. Now you see, this 30 and this 40 are not, 39 and 40 are not the same. Similarly, this 49 and 50, okay, are not the same, right? So that's why you would find such kind of basically writing of the class is called inclusive continuous frequency distribution. When you write the classes in such a way, it is an inclusive continuous frequency distribution. So the classes over here you would find is 10 to 19. Why 10 to 19? We have started from 10 to 19 because our lowest number was 1717 and we had seen the highest number was 99. That's why, and they had basically given us, okay, the class, one of the classes as 30 to 39. So over here the first class is 10 to 19, 20 to 29, 30 to 39. It will go on till 90 to 99. Then seeing to those numbers, we shall basically mark the, we'll put up the tally marks, right? And counting those tally marks, we will put up the frequency. See over here, children. If we count the tally mark, if we count the tally mark, you would find the first row shows 5. Then again it is 5. Then the group of two groups of 5, that is 5 plus 5, 10. Then 3. Then 8. Then 5 again. Then 5 plus 2 is 7. Then 4. Then 3. And then if when you will just add them, okay, when you will add, okay, all these numbers, right, you would find it will come up to 5050, and that is our total frequency. That is the total number of days, right? So that is how you do this sum, and this is an inclusive continuous frequency distribution. This is an inclusive continuous frequency distribution. Okay, children, now we shall see to the fourth sum. What they given in the fourth sum? By considering the inclusive frequency distribution obtained in example number 3 and find exclusive frequency distribution. Now they have told us to find out the exclusive frequency distribution from the inclusive one. That is the first question, and they have told the second question, frequency distribution showing the mid value of each class. They have told us to find out the mid value of each class. Now first of all, we will try to convert the inclusive frequency distribution into the exclusive frequency distribution. Now see, children, this is the exclusive frequency distribution. As you have seen over here, 29.5, as we have discussed earlier, this 29.5 and this 29.5 are the same. Similarly, you would find this 39.5 and this 39.5 are the same. That is, you would find the upper limit of the given class, okay, and the lower limit of the next class are the same, and you would also find that the lower limit of the given class and the upper limit of the previous class are the same, and that's why it is an exclusive, okay, continuous frequency distribution. They have told us the inclusive frequency distribution which was there in our sum number 3, that is to be converted into exclusive one, right? So over here, how we shall convert? You would find, if you see to the previous sum, okay, the third class was 30 to 39. The third class was, say, 30. The third class was say 30 to 39. Okay, so 30 to 39, as per the formula, the lower limit of the given class, the lower limit of the given class is 30 plus, you would find the upper limit of the previous class. Now what would be the upper limit of the previous class? the upper limit of the previous class would be 29, okay, whole divided by 2. This is the formula. That is, you would find the upper limit of the given class, the lower limit of the given class, right, and you would find the upper limit of the previous class whole divided by 2. So if we take say 30 to 39, if we take say 30 to 39, you would find if the class is 30 to 39, right, you would find how we will find out the exclusive classes. How we will find out the boundary point? Our lower boundary point will be say 30 plus 29 whole divided by 2, and that will give us 29.5. That will give us 29.5, and this 29.5 is what is the lower boundary point. Over here you would find, okay, this is the lower boundary point, 29.5 of the given class. Now see, this is the exclusive frequency distribution. This is the exclusive frequency distribution, right, because the numbers are the same, the limits are the same, right. So that is what the we have converted the inclusive into the exclusive one. That's why the first class would be 9.5 to 19.5, then 19.5 to 29.5, 29.5 to 39.5, and it will go on till 89.5 till to 99.5. Then again, what you are going to do? You are going to have you have to write the frequencies. We have already found out the frequencies in our last sum. That only we will write over here, and yes, you got your total to be 50. That is how we had converted the inclusive, okay, classes into the exclusive one. That is how we have converted into the exclusive one. In this sum, they have also told us to find out the mid value. Now, how do we find out the mid value? Children, you will always find the formula to find out the mid value is upper limit plus lower limit divided by 2. Upper limit plus lower limit divided by 2 of the given class. Okay, when you will, for a given class, if you take the upper limit, as you add the lower limit and you divide by 2, you will always get the mid value of that particular class. So over here, with the help of our inclusive frequency distribution, our first column is our inclusive frequency distribution, right? So over here, see, for 10 to 19, it is 10 plus 19 divided by 2. As you use your calculator, it is coming up to 14.5, and that 14.5 is our mid value, and our frequency distribution was 5. Similarly, you would find over here we need to concentrate on the mid value. The next class is 20 to 29. So what we did is that we just added 20 plus 29 divided by 2. Use your calculator, you will get 24.5, and this say 24.5 is what? This 24.5 is our mid value. This 24.5 is actually our mid value. Similarly, see the next one. It is 30 to 39. So what you are going to do is that over here 30 plus 39 you added, you divided by 2, you got 34.5. Again, what is 34.5? It is our mid value. Similarly, you get the mid value for subsequent classes, that is 44.5, 54.5, 64.5, 74.5, 84.5 and 94.5. So you are going to use the same formula for the mid value for all the given classes, right? And that is how you find out the mid value. So over here in this sum, we saw how to find out or how to convert, I should say, your inclusive frequency your exclusive continuous frequency distribution to inclusive continuous frequency distribution, and how to find out the mid value. Now here children, we shall discuss example number 5, right? What they given, the following frequency distribution of unequal class length is obtained for sum data, prepare a frequency distribution stating the class length and the mid value of each class. Over here, children, the class length are inappropriate. Now the class length are inappropriate, that is, you will not find equal class length, right? Some can be of 20, or one or two classes could be of some other class length, right? So all the class length over here, the class length is not at all appropriate. All right, from that we need to prepare what they have told us to find out the mid value for each and every class, and also state the class length for each and every class. Now how we shall do this? See, the classes have been given to us. Our first column would be of classes. It has been given 0 to 20, 20 to 50, 50 to 70, 70 to 90, 90 to 100. That is, you are going to write it from the table above. Then similarly, over there they have given us the frequency. Frequency you should take always at the last. That is, you can say 20, 30, 30, 15, 5, and the total will come up to 100. The total will come up to 100, right, if you will add the frequency. Then how you are going to find out the class length? The next one is of the class length. Children, always remember that when you talk about class length, your class length is always denoted by capital C. Your class length is always denoted by capital C, and the formula to find out the class length is always the upper limit of the given class, minus the lower limit of the given class. There is the upper limit of the given class minus the lower limit of the given class, that will give you the class length. So C is equal to UL, that is upper limit of the given class minus the lower limit of the given class, or many times you can also take as boundary points, that is upper boundary point of the given class minus the lower boundary point of the given class. So see over here, children, we need to find out the class length for each and every class. So over here you would find our first class length of the first class, that is 0 to 20, is 20 minus this 0 will give you 20. 20 minus 0 is 20. So the class length for the first class has come up to 20. Similarly, 50 minus 20 will give you 30. Similarly, this 70, that is the upper limit of the given class, minus the lower limit of the given class, that is 50. 70 minus 50, the class length that you got is 20. Similarly, 90 minus 70 will give you 20 again. Then 100 minus 90 will give you 10. If you see this, the class length of each and every class has come up to 20, 30, 20, 20, 10, and you would find these are not the same. Okay, all these are unequal class length. Now how we shall find out the mid value? They have given us two questions to find out the class length, that we have found out. Now we are finding out the mid value. Now for the mid value, it is always, we have seen that your upper limit plus your lower limit whole divided by 2. So over here, children, from here you would find 0 to 20 is given to you. So 0 plus 20 divided by 2 will give you 10. Similarly, see this one, your 50 and 20 is that. So 20 plus 50 whole divided by 2 will give you say 35, with the help of the mid value formula that we have seen in our previous sum. Then 50 plus 70 whole divided by 2, that is giving you 60. 70 plus 90 whole divided by 2 will give you 80, and 90 plus 100 whole divided by 2 will give you 95. All these are what? All these are the mid value, okay, that what we found out, right? So we found out the class length and the mid value of each and every class as they had told us to find out, and say the frequency also we have stated into our sum. So that is how do we do this fifth sum. So children, today we'll stop over here. In our next video we will continue from example number 6, right? So children, God bless you all, and practice these sums, right? You will definitely come across this sum, and definitely I assure you that you are going to get the answers. God bless you all.